So we'll shift from doing two proportion intervals to two sample mean intervals. So again, as a reminder, just any confidence interval, keep in mind, was your statistic plus or minus a critical value times the standard deviation of the statistics. Remember before we talked about those statistics, you basically have two statistics to work with, p hat or x bar. Well, today, in this particular video, we're going to deal with x bar. The critical values, it's either a z star or a t star. And today we talk about both of those because we're talking about means. And then the standard deviation of the statistic, which we will also call standard error. Right? So the standard area for a two sample interval, right? This one for means. If you look on your yellow sheet into that table, we can start to see what that looks like. And if you look in, like I said, into that table, you can see the two sample table, the difference of sample means. We're going to end up with sigma 1 squared over n1 plus sigma 2 squared over n2. And you're going to come back and take the square root of all that. Again, we add because you always add variances. You can see right there you are creating variances by squaring the original standard deviation. So there's two different types of intervals. You got your t interval and your z interval. Remember, t interval, sigma is unknown, which means what we do know, so we know s, which is the sample standard deviation. This is the more likely scenario. So a two sample t interval means we're going to do x bar 1 minus x bar 2. There's your statistic, plus or minus, since this is a t interval. We do t star, and then here sigma is unknown, but what we do know is s, the sample standard deviation. So we do s1 squared over n1, s2 squared over n2. If you do know sigma, if you know the population standard deviation, the first part of this is going to be the same. We're going to subtract our two means, but this time we're going to use z star, and since we know sigma, we're going to plug it in to the formula. All right? Anytime you do a t interval, there's always going to be degrees of freedom. This is how we're going to get our critical value out of that chart, or potentially using your calculator. Remember, degrees of freedom before was n minus 1. Well, it's a little bit more tricky now, so we're going to let the calculator tell us. And it will. If we run this the right way, the first thing that it'll tell us in our menu is how many degrees of freedom. And oftentimes it's going to be some kind of crazy decimal. All right? As is always the case whenever we do these intervals, there's always conditions. The first, we're going to make sure they're both from an SRS. The next one for us here is either they're both normal or large. And we've seen it before. 30 is a good cutoff. Some people would say maybe 20 or 25. But large samples allow us to use normality. We've seen that over and over again. And then finally, this is the first time we've seen this one. We want to make sure the two groups are independent. So you think about yesterday when we did the heights of the guys versus the height of the girls. A girl's height did not affect the guy's heights. The guy's heights did not affect the girl's heights. Even with the GPAs, a girl's GPA is not going to affect the guy's GPA. So, and the next thing with these means, let's make sure that we label our two populations. Whoop. Make sure we label our populations. So, let's do a couple practice problems. So here's I guess a exercise or an experiment in a little bit of human psychology, I guess. So the researchers at the University of Newcastle did this experiment to see whether the images of eyes watching would change employee behavior. So they took a picture of flowers and they alternated it with a picture looking at the viewer, just eyes. So maybe like a portrait. So it's a portrait with eyes versus flowers, back and forth. That wasn't 5 randomly selected weeks. This looks like a lot more than 5. So that's 1, 2, 3, 4, 5, 6, 7, 8. They did 8 weeks of this for each one, and it's random. Does it appear that having watching eyes has an effect on the voluntary payments? Well, this is a two sample, right? We're comparing two samples. We don't know sigma, so it's a two sample t interval. Since we wrote t, we need to go ahead and jot down that we're going to get degrees of freedom in just a minute, but we'll get there. Um, Conditions, they're both from a random sample. That's given. Um, Here, not sure. They're not big enough, but what we can do, we're going to have to put this data in the calculator so we can check for normality. And the two groups are independent. Whether there's eyes there is not going to affect whether or not there's flowers there. So we can go ahead and say this one with some confidence. So the formula, all this, we're going to take a moment and put all that data into your calculator. So take a moment and do that. And I'll pause my video. You can pause yours at this point as well. So I've taken a moment and I'm putting that data into the calculator. And what I'm going to do, like we kind of started looking at yesterday, I'm going to go ahead and grab that 2 sample t interval. And I've put the data in there, right? So we've got data. So that's the function I'm going to use within that 2 sample t interval. So I put my data in list 1 and list 2. There's no frequency. And then confidence level, I'll do 95% because we're all pretty familiar with that one. So 95%, and then go down to calculate. So I've already got my interval. It's going to pop up for me from negative 0.64 up to 523. So I'm 95% confident. True difference. In voluntary amounts given for flowers versus eyes is in the interval negative 64 cents up to $5.23. Because 0 is an interval, there appears to be no significant difference. So now that I'm looking at my data here, I can go ahead and put what I need to put in here, x bar 1. So this is one of those things I mentioned before. So population 1 we're going to call I, painting, and then population 2, this is just so we can make sure we put stuff in the right way. Before we had p hat 1, p hat 2, which kind of labeled stuff. Now we just need to write it down. So the formula for us, x bar 1, I'm just looking straight at my chart, or at my output. So 1581 minus x bar 2, 1352. I'm going to have to go get that t star value. But I do know that S1 is 294, so I do 294 squared over 8. My S2 is 251, do it squared, again, over 8. Now I need to go look in a t-table, right? And if the very first thing that I was given, right, I'm just kind of backfilling all this information, 13.6, 6. So I'm going to go to 14 degrees of freedom. I'm going to get a T-star, 14 degrees of freedom, 95% confidence interval. So just go to your T-table, go to your 95%, and then scroll to 14, and that gives us a T-star value of approximately 2.145. And we're done. So one more example here. I'm going to do part B. Is there a significant difference between the number of pegs that males and females can place in a minute? So here's this data, and it's data that's collected on a sample. We do not know the population standard deviation. So this is a 2 sample t interval. The first one, I'll go back to in a minute. So we need degrees of freedom again, the conditions, both from an SRS. Here, both N1 and N2 are greater than 30, so we're good. We've got big enough samples. And the groups are independent of each other. we're going to call population 1 males. Population 2, just squeeze that in somewhere so somebody that's looking at your work can follow you. And so we'll put our data into the calculator, or excuse me, I should say our statistics. We have a 2-sample t interval. We have the statistics here. So x bar 1, 19.39. The first standard deviation, so 19.39. The first standard deviation is 2.52. First sample size is 50. We have 1791 with a standard deviation of 3.39. 50. I'll stick with 95% confidence. And then we're not going to pool, never going to pool. So my interval here, 0.29 up to 2.67. So 95% confident. True difference in average matches, average number of correct matches is between 0.29 and 2.67 because entire interval positive. It appears population 1 males had a higher average number of correct pieces. So we'll go back and backfill the formula now. So x bar 1 was 19.39. X bar 2 is 17.91. I'm going to have to go get that degrees of freedom. So let me fill in the rest here. 2.52 squared over 50 plus 3.39 squared over 50. So the degrees of freedom were 90.49. So take it or leave it. I guess I'm going to go with 90. I don't even know if that's an option for me in the chart. It's not. So I'll probably go with a T-star for 100 degrees of freedom, 95% confidence. So 100 degrees of freedom, 95% confidence, puts you at 1.984.